Thank you for joining us today on Debate Live. Tonight we'll be debating whether or not the tangent is perpendicular to the radius. This is Carl, and this is Hunter. Hunter believes that the radius is not perpendicular to the tangent when he does. Hunter, you have 1 minute and 30 seconds to defend yourself.
Thank you, Your Honor. As you can see, I have sufficient evidence that the tangent is not perpendicular to the radius. As you can see in this picture, AQ acts as the radius in circle A. Now, AQ is nowhere near where this tangent touches at point T. This proves my theory that tangents are not perpendicular to the radius. Now, although the radius can go anywhere in the circle, the tangent can hit the circle at any other point, proving that the radius is not always perpendicular with the tangent. However, there could be yeah.
Thank you, Hunter. Carl, you have 1 minute and 30 seconds to defend yourself.
Okay, it's my first time, so wish me luck. Okay, I have my case well defended. Yeah. Here, look. I have my circles drawn out, and see, this is the tangent. A circle is just a bunch of points, all equidistant from the center point. So when the radius is the same length all the way around, so all of the points are equidistant, okay? And with a tangent, it will only intersect through one point. So if it's only for each one point, the tangent is going to be exactly the same, okay? That's not to say the tangent for this point is going to be the same as the tangent touching that point. But the tangent touching this one point, the line will always be the same. So when the radius intersects with that point and the tangent intersects with that point, it will always cause a 90-degree angle. Did I do good?
Yes, thank you, Carl. You now have 1 minute to argue with one another.
Well, you see, I'm a veteran arguee, debater, whatever you want to call yourself. And I have pulled out the definition of a tangent and a radius. So as you can see, a tangent is something that meeting at a curve or surface in a single point, like it meets at a circle at a single point. And then in a radius, the radius's definition, it says that the radius is a line segment extending from the center of a circle or sphere to the circumference of or bounding surface. Now, there's nothing in the dictionary that proves that a radius is perpendicular to a tangent, and it doesn't prove that a tangent is perpendicular to the radius. This is my argument.
Okay, and now my argument is, how do you say, common sense? All right, let's look at this. Okay, so a tangent will only run through one point on the circle. So it will be, as you can say, like, if you look at that point and make it perfectly on the top, it will always be horizontal, all right?
But I know what a tangent is, I know what a radius is, and I'm telling you that they're not perpendicular.
But they are. See, the radius, like if you always put that one point, no matter how you shift the circle, those two lines will always be the same. But just for demonstration purposes, we're going to put it on the very top point of the circle. If you put it right on the top, the tangent line will always be perfect horizontal, and the radius will always be perfect vertical, causing it to be perpendicular, causing 490-degree angles. Now, it doesn't matter how you move the circle, but these two lines, as long as they intersect at that same point, they will always be the same.
Well, Hunter, looks like you
been beat.
Thank you. Sit down.
You
In
don't.
conclusion,
Get your silk out.
a circle such as this is circle P. And at this point, T, you draw a tangent. Or, yes, tangent. This is a radius. This is this, and this. And so is any other point you can think of. But this particular radius happens to be perpendicular to the tangent, creating a 90-degree angle.